This video we will be learning about electrical energy and power. Electrical energy is a form of energy. If energy transferred in moving q amount of charge under a potential difference of delta V across a device, the energy is given by W equals Q times delta V. Power is the work done per unit time. Therefore, if we divide work by time, that is Q delta V by time, we get P equals Q delta V times Q over T. And also, current is the charge flowing per unit time, that is I is equal to Q over T. Therefore, we get P equals delta V times I. Also, if current flows from high potential to a low potential across a device, this device consumes energy. Similarly, if current flows from a low potential to a higher potential across the device, this device will supply energy to the circuit. Now we have to learn about the rate of supply of electrical energy to a circuit by a cell. Let's say we have a cell. The electromotive force is E. The current flowing across it is I. So by the equation P equals delta V times I, here the voltage difference across this cell will be equal to E. That is the electromotive force of the cell. Therefore, P is equal to E times I. So for a battery, in order to find the rate of supply of electrical energy, we use the equation P equals E times I. For an example, let's say we have a battery of 6 watts and the current flowing across it is 2 amperes. Therefore, the power is equal to E times I. Here E is 6 watts and the current is 2 ampere. Therefore, the power will be 12 watts. Of the rate of dissipation of energy from a resistor. This is a resistor of resistance R and the current flowing across it is I, and we have a voltage difference of delta V. So by the equation P is equal to IV, and also we know V equals IR. So instead of I, if we subject V over R and we substitute in this equation, we will get V over R times V, that is V squared over R. And if we take this equation and subject V from P equals IV, if we replace V, we get I squared R. Therefore, we have two equations. Power is equal to V squared over R and P is equal to I squared times R. Now let's move on to a question. Find the ratio of power between the two resistors in each case. So this is the case 1. This is the second case, okay? Right. So here, let's say the the voltage drop across the two resistors is V, as and it should be the same because these two resistors are in parallel. Here, if the current flowing is I, the same current will flow across these two resistors because they are in series to one another. So if you consider the first case, let's say this is P1 and this is P2. So we have to find the P ratio between P1 and P2. Since the voltage is the same, we can use the equation P is equal to V squared over R. for the R resistor, P1 is equal to V squared over R, and for 2R resistor we get P2 is equal to V squared over 2R. So if we take the ratio, P1 over P2 is equal to V squared R times V squared 2R, so that will be 2. And if we take the second case, since the current is the same, we can use the equation P is equal to I squared R. So for R resistor, P is equal to I R, that is P1. For 2R resistor, P2 is equal to I square times 2R. So if we get the ratio between these two, P1 over P2 is equal to I squared R over 2 I squared R, then we will get 1 over 2. So that is how we can use these equations to get the ratios. If the voltage drop is the same, or if these two resistors are in parallel, we can use the equation P is equal to V squared over R. And if they are in series, we can use the equation P is equal to I squared R. Let's move on to the next question. In the first part, we have to find the rate of heat dissipation from each resistor in the circuit. First of all, we have to find the current flow that is flowing across the resistors. So let's say this current is I, and this is I1, and this is I2. So in order to find I, we can find the equivalent resistance of this resistor network. So that is 1 over Req is equal to 1 over 3 plus 1 over 6, and we will get 6 over 3, that is 1 over 2. Therefore, Req is equal to 2 ohms. That is the total resistance of this part. Then we have a 3 ohm resistor along with the 2 ohm resistor. So we will get an equivalent resistance of 5 ohms. So the circuit can be replaced by a single resistance of 5 ohm resistance, and the voltage difference or the EMF of the cell is 15 volts, and the current is I. So by the equation V equals IR, you can find I, that is I will be 3 amperes. Now we have to find I1 and I2. I1 can be taken from the equation R2 over R1 plus R2 times I. So R2 will be 6 ohms, and R1 is 3 ohms plus R2 is 6 ohms. Then I will be 3 amperes, so that will be 18 over 9. We get the answer 2 amperes. So similarly, I2 will be R1 over R1 plus R2 times I, that is 3 over 3 plus 6 times 3, that is 9 over 9, and we get the answer 1 ampere. So we can find P1 now. P1 is the resistance of this one. So P equals I squared R, and that is I1, right? So 2 squared times 3, that is 4 times 3, and we get the answer 12 volts. And P2 is equal to I2 squared times R, and that is 1 squared times 6, and we get the answer 6 volts. And P3, that is this one. So this is P3, and this is P1, and this is P2. So the resistance is 3. So the current is 3. So that will be 3 square times 3. And we get 27 watts. So those are the rate of heat dissipation from each resistor in the circuit given. Now we have to find the total power dissipated from the resistors. So we have to just add all these. So P total will be P1 plus P2 plus P3, that is 12 plus 6 plus 27 watts. And we get the answer, 45 watts. Next question. Here, what is the rate of supply of electrical energy from the battery? So we have a battery of 15 watts and the current flowing is 3 amperes. So we can use the equation P equals EI. So there is 15 times 3 and we will get the answer, 45 watts. Next part. If the battery is connected across the equivalent resistance of the above resistor network, find the rate of dissipation of heat from the equivalent resistor. So this is what they are talking about. This is the equivalent resistance. So let's redraw the diagram. This will be 5 ohms and the current is 3A. So we can use the equation P equals I squared R. That is 3 squared times 5 and 9 times 5. We get 45 watts. Now let's move on to another question. Question number 3. An appliance is marked as 40 watts and 100 volts. So this is known as the power rating. And that is the maximum power it can handle safely or without getting destroyed. One. So in the first question, they're asking the power when it's functioning properly. So that will be 40 watts. This one. So in the second one, find the power when connected to a potential difference of 50 watts. Right. So initially, if this is the resistor, it can be anything. So let's say it is R, and the voltage supplied is 100 watts and the power will be 40. So by the equation P equals V squared R, here P is 40 and V will be 100 square and R we don't know. So that is the first equation. Now the potential difference is 50. So the same scenario. The only thing that is different is the potential difference. So this is P1. So for this, if we write the same equation, P, let's say it is P1 and V will be 50 square and we have R. So if we divide 2 by 1, we get P1 over 40 is equal to 50 squared over R times R over 100 square. And P1 will be 50 over 100 whole thing square times 40. That is 1 over 2 square times 40, that is 10 volts. Next, we have to find its resistance. So in order to find its resistance, we can use this equation. So this is the third part. So 40 is equal to 100 square divided by R. Then R is equal to 100 square root of 40, that is 100 times 100 divided by 40. So this will be 250 ohms. Next, we have to find the maximum current that can flow through the appliance without damaging it. For this, we can use the equation P equals I squared R. So P is given, that is 40 watts, and I squared times 250. So I square is equal to 40 divided by 250. So if you take the root value, I is equal to over 5. That is 0.4 amperes.